Okay, Assalamualaikum and hello. So can you hear me? Hello?
Yes, doctor, we can
Yes,
hear
I
you.
can hear you.
Okay, good. So this one is already in the tutorial session. So you can see here example 3, 4, 5, 6, 7. Okay, don't have any answer. Okay, so for today, let us do this tutorial. So you have to take out your paper, okay? Or maybe it's quite harder to share here. Okay, so I will ask you what to do, okay? So for example 3, okay? So you have to develop this skill, you have to extract the information from this one. Okay, what the first information you have, you can tell me, okay? Okay, so what is the information that you can extract from here? So I try Fahim. Can you tell me what is the information available? All of this? Fahim, are you here? Hello?
Yeah, it's doctor. I'm here.
Okay. So, can you tell me what is the information, all of the information available from the text, from the question? Okay, the first, what is the first? Okay, this is a very important skill. You have to know how to extract this.
I can't. So
Okay, so you can see here a coil of 200 turns. So what is this mean? A coil of 200 turns. You know what is it? Because if you cannot extract the information, you cannot use the formula.
I don't know, doctor. Sorry.
Okay, you can see here is turn, right? Number
Yeah,
of turns.
200 turns. Yes.
So n is equals to 200. Number of
Okay.
turns. Okay. Okay, next. What is, okay, wound uniformly over a wooden ring across the mean circumference of 600 millimeter. Okay. So you have two information here. Wooden ring. What it mean by wooden ring? What is wooden ring permeability? Relative permeability. Okay. What is the relative permeability? Or I will call another one. How about Mosadat? Are you here?
Yes, doctor.
Okay, Mosadat. What is, you can see what is mu r for wooden ring? Wooden ring is insulator, right? Remember that I say insulator has mu r equal to
600 mm.
300?
600.
No. For insulator and free space, mu r always equals to unity. Okay. So make sure
Okay,
you
doctor.
remember that. Okay, mu r is 1. Okay. So
Okay, doctor.
what is mean circumference of 600? Okay, let me call somebody else. Okay, Zakaria, how about you? What is that mean? Remember, circumference is what? Do you remember what is circumference?
There's, I think it is.
So what is mean?
Okay.
Okay, another way to look it, you have to look at the unit. You can see there is no square, right? Okay,
Yes.
if there is no square, means that it's L.
L.
Okay, so 600 And
If there is
remember,
no square, it will be L, right?
yeah, if it is square, it is area.
Okay.
Okay, and remember, you have to use SI unit. So 600 millimeter, you have to divide by milli is 1000. So 0.6 meter. Okay, this one, uniform cross-section area is 500 millimeter square. Okay. So this one, of course, you have to change it 500 because it is milli divided by 1000, and don't forget to square because this is square, millimeter square. So use your calculator, 500 divided by 1000 squared. So you get 5 multiplied by 10 negative 4. Okay, meter squared. Okay, always change it to the SI unit. Okay, if the current goes to the coil at 4 ampere, so you can also look at the unit 4 ampere. So means that I is equals to 4. Okay, 4 ampere. So this all the information that have been given. Okay, so the question is find magnetic field strength. Okay, so magnetic field strength is actually H. Okay, find the flux density. Flux density is B, and find the total flux. This is flux. Okay, so you have to recall back the formula which is hash is, because you want to find hash, you have to find flux multiplied by S or N multiplied by length. So from this, sorry, this one is hash is sorry, this one, sorry, F divided by L. Okay, is it correct or not? Okay, so you can see here, F is and I L. So you have two options. Either you have to use this one or this one. So I suggest you look at the information available, and you have to see which the information is complete. Okay, you can see that this is complete. This one is not complete. Okay, so use this formula. So hash is equals to Ni divided by L is equals to 200 divided by multiplied by 4 divided by the length is 0.6. So 200 multiplied by 4 divided by 0.6. So you get 1333.33. Okay, so ampere turn divided by meter. Okay, so you get the first answer. Okay, and then the question asks you to find B. So remember, B formula is mu hash, or equals to flux over area. Okay, so you can see here, you have flux, you have area, or you have hash, you have mu. Flux, I think is not available, right? Okay, flux not available, so you cannot use this formula, so you can use this. Okay, so B is equals to mu naught mu R and hash. So hash you already calculated, and mu naught, okay, mu naught is mu naught, okay, constant. Mu R is 1. Okay, and hash is this one, so equals to mu naught. Okay, mu naught, you can use your calculator, or you can memorize the formula for memorize the constant. 10 negative 7, I think. Okay, and for wooden, okay, remember mu R for insulator is 1. and then hash is 1333.33. Okay, so B is equals to 4 multiplied by so you get 1676, okay, multiplied by 10 negative 3 Tesla. Okay, so you can see here this one use micro, so this one is milli. So the answer is almost the same. Okay, so lastly, remember you have to find the flux. Okay, so to find the flux, remember the formula here. B is equals flux is equals to B area. Okay, so either this one or F divided by S. So if you check here, you don't have reluctant. Okay, you also okay, this one you have, okay, but this one you don't have. For this case, you have both. So of course you choose this one. Okay, choose the easiest way. Okay, so 1.676 multiplied by 10 negative 3. So the area is, where is the area is, oh, okay, you have to convert it. Okay, the area is 5 negative 4. So 5 multiply 10 negative 4. So 1.676 negative 3 multiplied by 5 multiplied 4, okay. So you get 8.38 multiplied by 10 negative 3. Okay. Whatever. So the answer is the same. So make sure you copy this because there is no answer in the slide. Okay, so we move on to the next part. Example 4. Okay, so Mustaba, are you here? Mustaba, are you here? Okay, how about Ibnu Fayyad? Ibnu Fayyad, are you here? Hello? Okay, this is a tutorial session. You need to be active. Are you here? Okay, nobody here.
Yeah,
here, doctor.
yeah.
Okay. Somebody can try to extract the information. Okay, this is important because in the question usually they give in this form. Okay, you have to extract all the information. Okay, example 4. Somebody can extract the information?
Sure, doctor. Can I try?
Yes, yes, you can.
Okay, so the flux is 0.015
Okay, flux is 0.015, correct?
and the length of the air gap is 2.5 millimeter.
Okay, length of air gap. So the symbol is LG.
G.
2.5 mm. Of course, you have to convert it. What is the value?
0.0025.
Okay, correct. Okay, and then?
And the area is 200 centimeter square.
So the symbol is?
A.
Okay. So effective area. Okay. So this one gap also. 200 cm squared. And how to convert this?
200 divided by 100 square.
100 square.
Square. Yes.
Okay, is correct. So 200 divided by 100 square. Make sure you be careful with millimeter and centimeter. So this one is 0.02 meter square. Okay, so the question is what? What is the question? Can you see where is the question?
Calculate the magnetomotive force.
So what is the symbol for that?
Mm,
It has force, right? So
yes.
okay.
Okay.
Okay, if you can see here, you have flux, you have length, you have area. Okay, and calculate the mathematical force required for the flux waiver across the air gap. So because this is air gap, of course, what is the mu r? For air gap, mu r is
1.
okay, good. So for this case, you want to find F equals to H, L, or plug S. So if you look at the information, okay, so you cannot calculate it because you don't have this information. Okay, but you have this information and this information. Okay. So continue. So F is equals to plug S equals to flux length G divided by mu naught mu R and area G. So 0.015 multiplied by the length is 0.0025 and divided by mu naught mu R is 1, area is 0.02. Okay. So use your calculator, find the answer. So are you getting the same answer? Okay. Ampere turn. Okay.
Yeah, yes, Doctor, the same answer.
Okay. So that is how you solve the example number 4. Okay, make sure you take a note because there is no answer in the tutorial session here. Okay, next we move on to the next question. Okay. So, okay, somebody want to try how to extract the information? Okay, somebody want to try?
Yes, Doctor, can I try?
Okay, try.
Here the area is 500 millimeters square.
So the symbol is?
A.
Okay, so area, this one is core, right?
Yes.
So 500 millimeters square. And how to convert this?
500 divided by 1000.
And don't forget the square.
Yes.
Okay. So the answer is 5 multiplied by 10.
So 5, yeah, into 10 to the power minus 4.
Okay. So next, what is the information you can obtain?
We circumference of 400 millimeters.
So what is that? The
I
symbol.
forgot the symbol for circumference.
Small l. Okay.
Small l. Okay.
Yes. Okay, equals to, because you have to know the symbol because you have to use a lot of formula and formula use symbol. So you have to practice. Okay. So 400 millimeter, you have to convert this.
Divide by 1000.
Okay. So make sure you convert this. And next, what is the information? available.
Number of turns, n equals 200.
N equals to 200 turn. Next,
The flux density,
flux density. Where is flux density?
respective flux density is about 380.
Okay, so be careful, You try
Yes.
to read it properly. Okay, the relative permeability of the small steel for respective flux density is about 380. So you want to say this one is flux density or permeability? Relative permeability. Based on the wording.
It's the permeability, relative permeability.
Okay. So permeability is what? Relative permeability. Be careful. Permeability, they have 3. Okay.
Yeah.
So what is this? The symbol.
Mu
And
mu r.
okay. So 380.
80.
Okay. So the question is, want to find for A, what is? The reluctant is what? What is reluctant? Okay, reluctant is S, It's like a resistor.
Oh. Okay.
So remember S is equals to F divided by flux or L divided by mu A. So if you look here, the information available is this one. Okay. So this one usually we don't use it. Usually we just use this one. So S equals to L mu A. So S is equals to L is 0.4 divided by where is mu? So mu R, remember mu is mu naught mu R. Mu naught and mu R is 380, and then the area is 5 multiplied by 10 negative 4. So use your calculator. So I get wait, 1.6.
It's 1.25 into 10 to the power minus 6 for me.
1.25. So be careful, Check back your calculator.
I think I made a mistake.
Yeah. So be careful because usually the mistake is on the calculator, and if you mistake happen at the beginning, all of your answer will be wrong, and you can lose a lot of mark there.
Sorry, doctor, my calculator mode was something else. That's why.
Okay. So only the calculator mistake, right? So be careful, And the unit try to memorize it because it can be helpful to extract the information. Okay, we move on to the next question. Okay, they give a flux. So flux is 800 microweber. Okay, find C. Find I. Okay, find the current. Find I to produce the flux. This one flux 800 microweber in the ring. So for this case, remember I is equals to what is I? I is equals to flux S divided by N. Remember the formula? Okay, the original formula is F is equals to Ni equals to flux S. So I is equals to flux S divided by N. Okay, so flux you already given 800 This one is 1.675 multiplied by 10, 6, okay, divided by the number of turn is 200. So I is equals to 800 multiplied by 1.675 divided by 200. So you get 6.7 ampere. So that is how you solve this question. Okay. So next is example 6. Okay, this one is quite confusing, okay, because of the text. Okay, if they give the information directly, it is much more easy, but because of the text, it's much more harder. So, somebody can help me how to extract the information. So, what is the information available? Okay, somebody?
N equals to 500.
N is equals to 500. Okay. And then the mean core part. Okay, this one already given. IC 360 millimeter equals to 0.36 meter. And then, okay,
LG
this one
is 1.5.
Okay, so LG, sorry, this one is L. LG is equals to 1.5 mm equals to 0.0015 meter. Next.
Flux density is 0.8.
So flux density is, the symbol is?
I'm not sure, doctor.
Okay, this one, okay, make sure you know what is flux density. Flux density is B.
Okay.
Okay, B is, or you can know is Tesla. You can see here Tesla is B. Okay, so 0.8 Tesla required to actuate the relay. Okay, the core is cast steel with the field intensity 510. So what is this? Field intensity is what?
Is that H?
Okay, correct. H is the field intensity, or you can use the look at the unit ampere turn per meter. So 510 ampere turn per meter. Okay, this one is for the core. So be careful, This one, they don't mention it, so it should be all. But this one is hash at the core. Okay. So be careful, where is the location of the flux density? Okay, flux density is where? Oh, at the gap. Okay. Flux density is at the gap. Okay. So find the current. How to solve this? Okay. This one is quite complicated, Okay. Have any idea how to solve this? So F is equals to Ni equals to, okay, you can see here you have B and H. Okay, if you have B and H and you have length, usually we use the formula HL. Okay, but this one is just for one component, so you cannot just leave it something like this. You have to include everything. So HL for the core, length for the core, and plus H gap and L gap. Okay, remember there are two formula, either this one or flux S total. Okay, reluctant total. So either you have to choose which one is available. Okay. So now F is equals to SC is given 510. LC is 0.36 and plus HG. HG is not given. So what is HG? So LG is given here. LG is 0.001 Fine. Okay. So how to find hash G? What is hash G? So remember hash G is equal to mu. Okay. Sorry. So remember hash is equals to mu hash. B is equals to mu hash. Okay. So B is equals to mu hash. So because we already give B, so hash at G is equals to mu for G. Okay, the gap is only mu naught. Okay, because mu R is equals to 1. So Hg is equals to Vg divided by mu naught mu R and mu naught mu R. So this one is 1. So Hg will be Bg is 0.8 divided by mu naught. Okay. So F is equals to, so use your calculator, 510 multiplied by 0.36 plus 0.8 divided by mu naught, okay, multiplied by 0.0015. Okay, so you get 1138.53. So equals to Ni. F is equals to Ni. So I is equals to F divided by N. Okay, equals to 1138.53 divided by number of turn, how many? 500. Okay, why is different? Okay, let me check first. Can you spot the mistake? Can you see it? Can you see where is the problem with this? Okay, let me check my scheme. Okay. Oh, okay. Okay, already spotted. Where is it? Okay, you can see here. Where is the length? Okay, when the air gap length are 1.5 millimeter each. So this one is actually not 1.5 millimeter only. So be careful with the text, multiply by 2. So you have 2 air gap. So this one and this one. So when you have 2 air gap, you have to multiply by 2. Okay. So the air gap should be 0.003 meter. Okay, and this one is 0.003 meter. So this one should be 2093.46 Okay, same here. And divide by 500, you get 4.19 ampere. Okay, so that is how you solve the question. So make sure you be careful. This one only because of the one word you can get wrong answer, because the length is they only mention the length is only one part. So because you have to consider all the length, it should be 2 multiplied by 2. Okay, so be careful with the wording. Okay, next, compute the value of permeability and relative permeability of the core. Okay, so because this is series, you can see here this is a series circuit, means that the flux for the core is the same as the air gap. And because this is there is no mention of the fringing effect, the area at the core is equals to area at the gap. So B, because A at the core is flux at the core is equals to flux at the gap. So B at the gap is equals to B at the core. So you already have B, you already have hash. Okay. So mu is equals to mu naught mu r is equals to B divided by hash. Okay. So mu r is, oh, they want both, permeability and relative permeability. So mu is equals to B over hash. So B is, what is B is 0.8, okay, Tesla, and the hash is 510. Okay, so 0.8 divided by 510 is 1.56 or 7 multiplied by 10 negative 3. Okay, so this is the permeability, and mu equals to mu r is equals to mu divided by mu naught. So this one is 1.57 multiplied by 10 negative 3 divided by 4 pi multiplied by 10 negative 7. Okay, and the answer is, okay, the relative permeability is 1248.27. Okay, this one, the unit is Weber ampere meter. Okay. Okay, make sure you differentiate this, WB ampere meter. Okay, ampere per meter actually. So it's okay. For this one, there is no unit. Mu r don't have unit. Okay, and lastly, the air gap. If the air gap is 0, find the current in the coil for the same flux density. So what it means that, okay, B is 0.8 also. Let me this one. If the air gap is 0, so means that it's only this one. Find the current of the coil with the same flux density in the core. So you have B here, and find the I. I is equals to what? Okay. So how to solve this? Any idea? How to solve this? Find the I. Any idea? Somebody answer? What formula should we use? So remember, F is equals to Ni equals to flux S equals to hash L. So which formula you have to use? So you can see here there is no reluctance, so this is out. So the only thing that you need to use this one and this one. Okay. So Ni equals to hash L. So you want to calculate the I, right? So I equals to hash L divided by N. Okay. So because they will only have B. Okay. So B is hash is equal to B divided by mu naught mu R N L. Okay. So L of the core, mu naught R, okay, of the core, N of the is N, and B is the core. So I is equals to B core is 0.8. Length of the core is, what is the length of the core? 0.36, and divide by mu naught mu RC. What is the mu RC? Is 1250. You already calculated it. Okay, number of turn is 500. So I is equals to 0.8 multiplied by 0.36 divided by mu naught divided by 1250 divided by 500. So you get 0.367 ampere. Okay. Okay, don't worry. There is some of the error because of the approximation. Okay, you don't use all the value in your number, okay, calculation. So there will be some error. Okay, you want to, okay, this one is what series? Okay, this one is also a series circuit. Okay, time is almost up. So maybe we continue next week for this. Is that okay? Testing. Hello.
Good, doctor.
Okay, so we continue next week. I think it's already 12:30, right? You're already saturated from this.
Doctor.
Yeah.
Okay. So see you again next week. Okay.
All right,
Okay, thank
doctor.
you.
See you. See
Okay,
you.
welcome.